Alright, this is a video for 3HD about the diagnostic test of chapter 7. This video is about exercise 8 and 10. It says bird is flying a kite and the rope is 300 meters long. We can see that here. The angle of elevation of the rope is 35 degrees. That's this. What is the altitude of the kite? So we want to know how big is this, because altitude means the height. So if you look at this angle, we want to know the opposite side. And we already know the hypotenuse. So we need to use the sine. So I'm going to write down over here for exercise A, the sine of 35 equals the opposite side that we don't know divided by 300. So if I do 300 times the sine of 35, then we get the answer. So 300 times the sine of 35. That is 172.07 meters. Question B. After a while the wind picks up and the kite reaches a height of 240. So now this is 240. Right? Calculate the angle that the kite makes with the ground. Here the angle changes, but this rope stays the same. So the rope doesn't change, only this is no longer 35. So now we want to calculate the angle. We still have to use the sine because we use the opposite side and the hypotenuse. But in this case we have to do, for exercise B, sine minus 1, because we have to calculate an angle. And then the opposite side is 240 and the hypotenuse is 300. Now if I type this into a calculator, I get 53.1 degrees. This is the answer for exercise 8. So just one more time how to calculate a sine and how to calculate an angle. Then we go to exercise 10. And we have cuboid A, B, C, D, E, F, G, H. AB is 5, that's this length, that's 5. AD is 3, that's that length, and AE is 2, and that's that length. We need to calculate angle BGA. So here's B, there's G, and there's A, so BGA is this angle there, at angle G there. If I want to calculate it, then first I think I should make a sketch, because then it looks a bit better. Because here we have a three-dimensional picture, and I don't like that. So here I'm going to draw a triangle ABG. Now you can see that angle B needs to be 90 degrees, so this one is 90 degrees. And furthermore, we know that AB is 5, so this one is 5. And then we don't know BG and we don't know AG. Well, we need to know this angle. So we need to calculate BG or AG using probably the Pythagorean theorem. So if you take a look at this, we can calculate BG here using the Pythagorean theorem with 3 and 2. So that's what we're going to do. So I'm going to write down that BG is the square root of 3 squared plus 2 squared. And if you work that out, this is 9 and this is 4. I forgot the square there. And 9 plus 4 is 13, so we have the square root of 13. So we're going to use that in our calculation, the square root of 13. So to calculate angle BGA, I do 10 minus 1 and then 5 divided by the square root of 13. Because 5 is the opposite side and 13 is the adjacent side. So I do 10 minus 1 and then 5 divided by the square root of 13, and then it tells me it's 0.2 degrees, and that's the answer for exercise 10. So you see how to calculate an angle using a three-dimensional shape, and it usually involves calculating a side first using the Pythagorean theorem. Now you can round this off to a couple of decimal places if you'd like, but if you try to keep it as exact as possible, then your final answer will also be the best it can be. So thank you for watching, and I'll see you later.